In this video, we're going to talk about RMS value of AC circuits. RMS stands for root mean square. And when dealing with AC circuits, it tells you the average power dissipation that would be equivalent in a DC circuit. So on the left, we have a 30 volt DC power source applied across a resistor. Now the power dissipation across that resistor is going to be V squared over R. That power dissipation is going to be the same if we apply an AC signal with a root mean square value of 30 volts. Now you need to understand the difference between the peak voltage and the RMS voltage. So the signal will look something like this. We would have a sine wave with a peak voltage that is higher than 30 volts. To calculate the peak voltage, it's going to be the square root of 2 times the RMS, or the root mean square voltage. In this example, the root mean square voltage is 30. So it's going to be 30 times the square root of 2. The square root of 2 is about 1.4142. If you multiply that by 30, you're going to get a peak voltage of approximately 42.4 volts. So that's the maximum voltage of this AC sine wave. As you can see, it's not the same as these two numbers. So to get the same power dissipation across this resistor, you need to use the RMS voltage of the peak voltage, and that is 30 volts. So that's why it's important to understand how to calculate the RMS value given the peak value, because the RMS value tells us what the equivalent power dissipation would be to that of a DC circuit. So we said that the peak voltage is equal to the square root of 2 times the RMS voltage. If we divide both sides by the square root of 2 and reverse the equation, the RMS voltage is going to be the peak voltage divided by the square root of 2. If we multiply the top and the bottom by the square root of 2, we get the RMS voltage is equal to the peak voltage times the square root of 2 over, multiplying these two, that's 2 times 2, that's 4. The square root of 4 is 2. So this is another way in which you can calculate the RMS voltage given the peak voltage. But where do we get this number? The square root of 2 over 2, where does that number come from? We're going to talk about that shortly. But here's the decimal value of this number. The square root of 2 over 2 is approximately equal to 0.7071. And we're going to talk about how we can get this value. So here we have an AC sine wave with a peak voltage of 1 volt. If the peak voltage is 1 volt, that means that the RMS voltage is going to be the peak voltage divided by the square root of 2. So 1 divided by the square root of 2, that's going to be 0.7071. So let's see if we can calculate that RMS voltage using the table on the right. So what we're going to do is we're going to find the RMS voltage of the first half of the sine wave. Now, going back to trig, the period of a sine wave is 2 pi. So this point must be 1 pi. And we're going to break it up into 10 equal parts. So the middle is going to be pi over 2. But if you break it up into 10 parts, 1 pi over 2 is the same as 5 pi over 10. So this is 0. This is going to be 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, and then 5 pi over 10. Next is going to be 6 pi over 10, 7 pi over 10, 8 pi over 10, 9 pi over 10, and pi is the same as 10 pi over 10. So we have voltage on the y-axis, time on the x-axis, but in terms of pi. So this here represents our x values. Now, to get the voltage at each of these x values, what you can do is you can plug it into the equation. So this is the function that we have above. This is a sine wave, so the function is just sine of t. So to calculate the voltage at pi over 10, just plug this into your calculator. Sine pi over 10. And make sure your calculator is in radian mode and not in degree mode. So this will give you 0.3090. So you get this voltage. Now, if you plug in sine 2 pi over 10, which is the same as sine pi over 5, you're going to get the next voltage on the list. And that's going to be 0.5878, which is a rounded value. So that's the value that we see there. And then if you plug in sine 3 pi over 10, you'll get the next voltage, 0.8090. And you want to continue that pattern all the way to 10 pi over 10, which is pi. Sine of pi is 0. Now the next thing you want to do is you want to take the square of all of the voltages that you have. So if you square 0.3090, you're going to get 0.09548. And if you take the square of 0.5878, you're going to get 0.34551. And so take the square of this column, and then you'll write the numbers here. In order to calculate the root mean square of a set of numbers, you need to square the numbers first, and then take the arithmetic mean of that, and then take the square root of the arithmetic mean, and that will give you the answer, the RMS value, which is what we're going to do. So right now we have the square of the voltages. We're going to take the sum of those squares divided by the number of intervals that we have to get the arithmetic mean of the square of the voltages, and then we're going to take the square root of that result to get the RMS value. So I know that was a mouthful, so let's go ahead and write that in the form of an equation. To get the RMS value, or the root mean square value, what we're going to do is take the arithmetic mean of the squares of the voltages. To take the arithmetic mean of something, you need to first get the sum, and then once you have the sum, you divide it by the number of terms that you have, in this case n. So that is the arithmetic mean of the square of the voltages. And then we're going to take the square root of that arithmetic mean that's given us the root mean square. So that's how you find the root mean square of a set of numbers. You take the average of the squares, and then you take the square root of that result. So first we need to find the sum of this column. So go ahead and take a minute and add up all those numbers in the last column. So it's going to be 0.09548 plus 0.34551 plus 0.65448, and then just add up the rest. And you should get approximately 5. I got 5.00012, but technically it's about 5. And we have 10 terms, so n is 10, and then we're going to take the square root of that number. So 5 divided by 10 is 0.5, or you could say 1/2. The square root of 1 is 1, so we have 1 over the square root of 2, and then we could rationalize that. So this will give us the square root of 2 over 2, which we know that to be 0.7071. And so, given a peak voltage of 1, we can clearly see that the RMS voltage is 0.7071. So that's one way you could show that the RMS voltage is the peak voltage times the square root of 2 over 2, as we can see here. So if the peak voltage is 1, the RMS voltage will be root 2 over 2, or 0.7071. Now it turns out that there's another way in which you can calculate the RMS voltage of a sine wave. But here's the general formula. So it's going to be 1 over t times the integral of from 0 to t of the square of the voltage function dt. So it doesn't matter if you have a sine wave or a triangle wave or a square wave. If you know the voltage as a function of time, you can calculate the RMS voltage. So let's do that regarding the sine wave that we have. So we're going to integrate it from 0 to pi. So in this case, t is going to be pi. So it's going to be 1 over pi times the definite integral from 0 to pi. And we know that v of t is sine t. So this is going to be sine squared t dt. Now, you can plug this into your calculator. The definite integral from 0 to pi of sine squared is pi over 2. And so this gives you the square root of 1 over 2, which is root 2 over 2, and that's approximately equal to 0.7071. Now, I'm not going to go over how to integrate this step by step, but you need to use one of the power reducing formulas to integrate it. What I could do, though, is put another link in the description section below that shows you how you can integrate sine squared, because I've done that in another video. And then you could apply those steps to get this answer if you want to. But that's how you can calculate the RMS voltage using calculus. It's by using this formula.